Well, good morning to you all, and thank you for being with us today to discuss the IEA detailed energy consumption data. As Roberta mentioned, I am Sonia Garcia, working in the team responsible for energy end uses and demand data and efficiency indicators built with the relevant activity data. Here's the agenda. We'll begin by understanding the demand side of the energy system and why it's essential to go beyond the sectoral level to focus on detailed demand end use data. Then we'll discuss how to classify end uses and fuels and how to collect this data across the different sectors. And finally, we'll provide an overview of the IA tools for data collection, including our energy end uses and efficiency indicators database, and we'll conclude with final remarks. Please feel free to ask any question either today or later via email. Let's start with the understanding of demand data within the framework of an energy balance. As you may know, a country's detailed data can be presented in an energy balance, a matrix that displays flows and products that is divided into three sections: supply, transformation, and final consumption. In the columns, we have the sources of energy, and in the rows, we have the origins and uses. Only in an energy balance, you can compare products since they are all reported with the same energy unit. This format allows an easy comparison of the contribution if fuel makes to the economy and their interrelationships through the conversion of one fuel into another. Here in the energy demand end use data, we focus only on the demand side, which looks at the second and the third block of this matrix. The second block counts for the transformations of primary fuels to secondary commodities and own use of the energy sector. And the third block, or TFC, total final consumption section, shows at the different sectors consuming energy, including industry, transport, and other sectors such as commercial and services, residential, and non-energy use. To truly understand energy consumption, we need to examine the details of how energy is used at the output level. This is how we consume energy across the different sectors. Another way to present an energy balance is through the following chart, the Sankey chart, which is exactly the reverse matrix compared to the previous tabular layout, with products in the horizontal dimension and flows in the vertical one. Visually, it is very interesting because the arrow shows the energy flows from production or imports to the transformation in the middle and to the final consumption on the right, with the corresponding exports, losses, and energy on use. And here again, we only focus on the demand side, which is the right part of the slide. But why do we need to look at the demand side of the energy system beyond the sectoral level? Energy consumption feeds four main sectors with different needs. Here at the IEA's EDC Energy Data Center, we categorize energy consumption into four main sectors: industry, which includes manufacturing and other industries like agriculture, mining, or construction; services, residential, and transport. In the IE countries, transport is the most consuming sector, with more than 1/3 of the consumption, but the remaining sectors contribute with a significant percentage to the total final energy consumption. Industry represents at 24%, and residential and services buildings represent at 20% and 15% respectively. As you can see, no sector can be left behind. They all weigh a significant part of the system. Also note that these shares vary significantly, particularly based on sectors or factors such as industrial development versus the maturity of the services sectors, or the dominance of transport depending on a country's side. We might wonder though, what are the underlying details of this consumption? Or which parts of the economy is the most sensitive to price? Or which subsectors are efficient and which one needs to help to improve? Or which are the most polluting sectors? We'll answer all these questions, but first, let's focus on what can we learn from it. Demand-side data are the pillars of modeling and policy activities. The availability of detailed demand-side data enables bottom-up modeling work and also a robust assessment of clean energy transitions. Particularly, collecting those data enables the tracking of energy efficiency improvements in the country and can be used for assessing, setting, and monitoring policy targets. And end-use data are the basis to develop efficiency indicators. Generally, energy efficiency indicators are intensities, presented as a ratio between energy consumption, which is measured in energy units, and activity data, measured in physical units. For instance, we can compute some indicators like the energy consumption of space heating per dwelling or per floor area, or passenger cars per passenger kilometers that give us important information. These indicators provide valuable insights into energy efficiency, consumption patterns, and sector-specific trends. The basis of the IES methodology can be summed up with this pyramid graphic. The top of the pyramid shows very aggregated indicators, such as the energy intensity of the whole economy, being TFC, the total final consumption divided by the total GDP of the country. This is an interesting proxy to compare the trend of various countries, for instance, but doesn't give many insights for policy decisions. The further down one goes, the more data one needs, with subsectoral and end-use data, along with the related activity data, for instance, tons of good produce or number of square meters of housing heated, one can identify the focus point for improvements, whether through investments, technological upgrade, social measures, and so on. But how can we classify end uses and fuels? First, as we saw in the energy balance, the third block of the matrix shows the total final consumption of a country. This total consumption is divided by sectors, which can be divided into end uses or subsectors. I will dig into the details later. Beginning with the industry sector, we can analyze and compare the most consuming subsectors by fuel. For instance, in this case, we can see the 6 most consuming subsectors for Mexico and Poland. Each of them uses different fuels with general trends and country specificities. Chemicals often depends on gas, while wood and paper might use significant amounts of biofuels and waste. For instance, also basic metals may rely mostly on fossil fuels or electricity, depending on technological choices. So here, we can see that while Mexico rely more on gas for most of the subsectors, Poland rely more on coal. So tracking these splits allows to anticipate the impact of policies and regulations, and is also essential for energy security analysis, especially for subsectors depending mostly on only one product. For this reason, we collect energy consumption data by subsector, where we collect data from paper, pulp and printing, the chemical and pharmaceutical products, the food and tobacco industry, the textiles, the automobile industry, and so on. And also, we collect activity data, which can be either value added, which is the contribution of a specific industry or sector to the economy, and physical output, the actual quantity of goods produced by an industry, measured in physical units. With this data, we can compute some indicators such as energy intensity of one specific subsector per value added, which are good to compare sectors, countries, and follow trends, or energy consumption per physical product, which can be helpful to avoid currency issues and excellent at plant level or to track technology deployment. Now let's jump to the residential sector. Fuel split by end uses gives crucial insights on our standard of living, and we can see the influence of the climate. For instance, residential energy consumption in Finland and Morocco shows significant differences. In Morocco, space heating accounts for a minimal proportion of the residential energy use, whereas in Finland, it dominates consumption along with the residential appliances. Additionally, the share and type of fuel used for cooking vary significantly based on lifestyle factors such as the habits of eating out, cooking methods, and also types of stoves. For this reason, the fuel split of most consuming end uses are central to understand the reliance on imports, the impact of prices variations, and also the design of emissions and efficiency programs. For the residential sector, we collect first the energy consumption data by end use, which can be the space heating, the space cooling, water heating, cooking, lighting, and also appliances within the households. And also, we collect the corresponding activity data, which can be population, number of occupied dwellings, also the residential floor area, and the appliances stock and diffusion. As for industry, we can compute indicators like, for instance, the overall space heating energy consumption per dwelling, or per floor area, or per capita, which will help us to evaluate heating efficiency and analyze behavioral patterns and demographical influences on energy consumption within the residential sector. Now, for the services sector, we usually categorize services activities into 11 subsectors. For instance, in this example, for Switzerland, about half of the energy consumption is covered by 3 subsectors: wholesale and retail trade, accommodation and food, and administrative services such as finance, insurance, real estate, or science. But the weight of each subsector in energy terms might not relate to its output expressed with value added. For instance, accommodation and food services for value added, it accounts for a 9%, and wholesale, retail, and trade accounts for a 23%. So the energy efficiency indicators here in energy consumption divided by value added shows that the wholesale and retail have a significantly lower intensity than accommodation and food services, because the ratio of the energy consumption per value added is smaller than the accommodation and food. This means that the wholesale and retail trade generate more economic value per unit of energy consumed, so they are more energy efficient. Apart from the energy data by subsector, we have started to collect also energy use coming from data centers. And also, as for the residential sector, we do collect space heating, space cooling, lighting, and other building energy use within the buildings used for these services purposes. Also, we collect the corresponding activity data, which, as for industry, can be value added, but also it can be number of employees and populations and services floor area. Finally, for the transport sector, we divide the transport sector into 4 main modes and fuels. And here we can see that in 2022, for the countries, road takes up to 90% of the total consumption, and oil products account for the majority consumption. But also, it's important to differentiate between passengers and freight, which is how much is consumed by cars and also by trucks. For instance, the share of passenger cars in Korea is around 50%, but for freight trucks, it's almost 80%. So looking at the activity data can help us to explain variations in energy consumption patterns, efficiency, driving habits, and car usage. The data that we collect here then is by mode, and also by segment, which is passenger and freight. And the needed activity data encompasses many different kind of data: vehicle stocks, distance traveled by vehicles, which we merge into VKM, and also vehicle loads, which is computed in either in passenger kilometers or ton kilometers. To end up this section, we can also perform the composition analysis once the picture is complete. This decomposition analysis disentangles activity, which is, for instance, the amount of use of or number of passengers and distance traveled, the structure, which is the modal switch, for instance, changing from cars to the bus, and efficiency, which could be load factors, engine efficiency, driving behavior, and so on. But how do we collect the data for each sector? In general, data collections can be categorized into 4 main sectors: administrative sources, surveys, measuring, and modeling. Administrative sources are often pre-existing bases which needs to be gathered, but are the basis of the collection of data and the starting point. Surveys, where one can get the data directly to the user source. This is costly but very effective, and a representative sample is key. Measuring, which cover limited uses but get robust data. It's powerful once in place, but needs dedicated equipment and careful use. And finally, modeling, which requires some solid data to be built and some expertise, and it can help to bridge gaps and transform some data. Some examples can be for commercial activities, which is for industry and services. Some information can be found through economic authorities, for instance, a Chamber of Commerce, regulations authorities, or tax reports. Buildings are often requiring the most varied data sources with basic activity data such as population, employment, or the buildings or floor area. Um, Most energy consumption data relies on a combination of surveys and also measuring base of the cases. And then finally, for the transport sector, many data exist from oil consumption to car sales or registrations, but these sometimes need a bit of manipulation and also modeling. Now let's have a quick tour in the IA tools regarding how to collect this data. First, we have an experience database to foster dialogue with other countries. The truth is that other countries' experiences are incredible, valuable resources when one needs to collect new data. And that's why the IR gathered online numerous data collection practices, along with some documentation. So you will for sure find some insights by browsing this tool, and we can put you in contact with the institution in charge of these data collections if needed. In addition, we maintain documentation with methodology and detailed country notes, as well as two manuals on statistics and policy making. You can find the link at the bottom of the slide. To complete and strengthen this framework, the IE also recently developed two guidelines to build national roadmaps. One is focused on the in general statistics, which is called Designing an Energy Statistics Roadmap. And the second one, shown in the slide, focus on the demand side. It aims first at helping countries locating their departure point and to identify the targets according to national interests and priorities. And finally, we are currently finalizing a toolkit to estimate disaggregated data to be published very soon. So the idea is to provide a simple and editable tool to models and use data from more commonly available data. So feel free to reach us if for any of these resources. And lastly, our database, which is called Energy and Uses and Efficiency Indicators, it was decided in 2009 in a governing board to start collecting efficiency indicators data, focus on the energy demand side data. So that's why the IA developed a questionnaire template based on a robust, harmonized methodology. This is a very detailed questionnaire and database that covers 31 member countries, 5 associations and 3 accession countries, and 22 beyond the IE family. And from all these data collected, the IA Energy Data Center compiles a large database available on our webpage and also a data explorer with a web interface to produce graphs and also browse our data, as you can see in the slide. So bringing it all this together, the energy demand and end use data is essential because it enhances policy effectiveness and decision making, improves the accuracy of energy modeling and forecasting, and also enables effective monitoring of energy transitions progress. So as we wish to include as many countries as possible, we are always working bilaterally with multiple institutions to make this database as representative and complete as possible. So we welcome any question or any experience on data, and recall that pretty much in a country has data about everything, but very often data is first collected on the most important sector and then expands. So if you are interested in collaborating with us, feel free to reach out via email, and we are always happy to work together to improve our energy demand and induce data collection. So thank you so much for the attention, and please feel free to comment our question, any questions now or later via email.